Hey everyone, for the last part of this chapter, we're going to be focusing on finding the areas of parts of circles. So we're going to have some new vocabulary here, and really these next 2 days are going to come from chapter 12. But since they're dealing with area, we pulled them into this chapter 10. So today we're going to be talking about areas of sectors. And so to be able to find those areas, we're going to have to be familiar with central angles, arcs, and sectors, and then we'll be trying to find those areas. So the first word we need to be familiar with is a central angle. And all a central angle is an angle whose vertex is on the center, or is the center, of a circle. So remember, the vertex is where the two sides meet. So in this case, this angle right here in blue would be my central angle because that vertex is the center of the circle. Okay, next we have arc. So an arc is an unbroken part of a circle consisting of 2 points on the circle called the endpoints, and all of the points on the circle in between them. So in this case, I can identify 2 different arcs. So if I look at these endpoints R and S, I can look here, so all of these points make up an arc of that circle. I could also take these 2 endpoints and look at all of these points in between, and that would be a different arc. And we'll get into more about those arcs in a later chapter. But for now, we just have to know it's kind of those points around the circle that are in between 2 endpoints. So now that we have that vocab down, we can actually talk about sectors. So what a sector is, a sector of a circle is a region that is bounded by 2 radii of the circle and their intercepted arc. So I'm going to draw a circle. And here's what I'm going to think of. Here's my center. So what I'm going to do is I'm going to draw in 2 radii. It can be any 2 radii. So I'm going to draw in 1 radius here and 1 radius here. Now, when we say intercepted arc, all we mean is the arc that's in between. So I'm going to look right here. Okay, so I've got a region that's formed by this radii, this radius, and then this arc that's trapped by those endpoints. And so the sector is just the region that's bounded by those 3 things. So it's really, if you think of it, just like a slice of the pie. And so I'm just going to put that. Okay, so it's just a piece of that sector. And actually, if you think of it that way, the formula is really easy to remember. So let's look at here. In this diagram, I have a sector. Now, we're going to name it by an endpoint, the vertex, and another endpoint of the arc. So in this case, our sector is going to be named sector A, C, B. Again, A and B are the endpoints of that arc, and C is the vertex of that central angle. Now, we know that this sector is just a part of a circle. So to find that area, we have to consider the area of the circle, so pi r squared, and then we just want to multiply by the fraction of that circle that we have. And to do that, we're going to divide by m degrees over 360. And that m comes from here, and it's really just the measure of that central angle. So this arc measure and this central angle are the same thing. So I'm going to make a note here. This m is the measure of the central angle. Okay, so all we're doing is we're taking a fraction of the area of the circle. Okay, so let's look at a couple of examples here. So for number 1, we want to find the area of the sector. It's going to ask us to give our answers 2 ways. So we're going to leave 1 in terms of pi, And then we're also going to round to the nearest hundredth. So we're going to have two answers here. And again, as with all the other areas, I'm going to need to see your work. I'm going to be really firm in this chapter that if I don't see work, then you're not getting credit for that problem. I need to see your setup. All right, so in this case, I'm going to first write down my formula so I know I'm taking the area of the circle times the fractional piece that that sector takes up. Now, in this case, they're telling me that this arc length, this 80 is giving me the arc length here, but I know that's also the length of a corresponding central angle. So that's going to give me my m. So now I have pi times my radius is 3, so times 3 squared, times my m we said is 80 over 360. Now, to get that exact, what I'm going to do is I'm going to type in everything except the pi into my calculator. So in other words, I'm going to do my 3 squared times, and I can use my n over d key to get the fraction. I'm going to do 80 over 360. So that's going to come out to 2. Now I just have to be careful to remember to add that pi back. So my exact answer is 2 pi square inches. Now to get the rounded, I'm just going to type in 2 and then the pi. It's going to give me 2 pi, but again, I can use these double arrows here to get that rounded. And I get 6.28 square inches. So make sure you're putting both of those answers so that you don't lose points. Okay, the next one's a really straightforward example. If you feel like you're ready, I would say just pause the video at this point and try it on your own, and then unpause it to check. Okay, so again, we're still just finding the area of a basic sector here. So we know that's the area of the circle, pi r squared, times the fractional part of that circle. In this case, our radius is just 1. And the m, they gave it to us as the measure of that angle. So I'm going to have 90 over 360. And again, at this point, it just becomes a calculator problem. So let's see, I'm going to leave pi out. 1 squared I know is just 1, but I could type that in. 1 squared. And then I'm going to type in my 90 over 360. And I'm just going to get 1 over 4, which if I multiply that by pi is going to give me pi over 4. And this time we have meters squared. So to get my rounded answer, I'm just going to do pi divided by 4. And I get 0.79, since I'm going to the hundredths, meters squared. Okay, so those are both very straightforward sector problems. So we're just going to do a couple more. One's more of a word problem, and then one is not too tricky. We just have to be careful about the information that we use in the problem. So let's look at a word problem on the next page. Okay, so here it says a farmer uses a spray irrigation system to water his circular plots that each have a diameter of 720 feet. Then to the nearest square foot, what is the area that is watered as the sprinkler rotates through a semicircle? So it kind of gives you an overhead view of some of these plots. So I'm going to draw a figure to help me out here. I know I'm dealing with circular plots, right? So I'm just going to draw a circle. And I'm told that the diameter of that circle is 720 feet. So now it says, to the nearest square foot was the area that is watered as the sprinkler rotates through a semicircle. So through a semicircle, that means my sector, right, is really just this whole semicircle. So really what we're doing is finding the area of a semicircle. But I'm going to go ahead and use the sector formula, and you'll see how it relates to just finding the area of a semicircle. So we said that our area is pi r squared, the area of the whole circle, times the measure of our central angle over 360 degrees. Now, in this case, we have pi. Our radius is going to be half of our 720. So we want to divide that by 2, and we get 360. Now, since we have a semicircle here, I know that my angle measure here is just half of a circle, or 180. Right? So this is really going to be 1/2. So really what we're doing is taking pi r squared and just dividing it by 2, which is our semicircle formula. Now, this one just wants to the nearest square foot, so I'm just going to go ahead and enter everything in and then round appropriately. So I'm going to put the pi in this case, because I don't need it exact, times 360 squared, and then 180 over 360. Now, that gave me the answer with pi in it, so I'm going to use my double arrows. I want nearest square foot, so it's going to be 203,575 square feet. Now again, if you had realized that was just the area of a semicircle, you could also just do pi r squared over 2, but that would give you the same answer. Okay, so the last one for today, again, we're just finding the area of this shaded region, this shaded sector. So our area, again, is just pi r squared times m over 360. Now, here's where we have to be a little careful. There's 2 things we have to look out for. We're going to take pi. Now, we were given the diameter here. So I know the radius is going to be half, so my radius is 5. Now, the central angle, I have to be careful because this angle is 72, but it doesn't correspond with my shaded region. Now, since I know this whole region is 180, to find the angle I'm after, I'm just going to do 180 minus 72, which is going to give me a measure for my central angle of 108 degrees. And that's the number I actually want to use in my problem here. So 108 over 360. Then again, we go back to our calculator. In this one, we will do exact and rounded to the 100th. So I have 5 squared times 108 over 360. So I get 15 over 2, and then I remember to multiply by pi, so I'm going to get 15 pi over 2. And I don't have units. I'm just going to put u squared for my units. Now, I need my answer rounded. So I'm going to do 15 pi over 2 to get 23.56 units squared. Okay, so that's it for sectors. We only have one more piece to this chapter before we're at the end.